All right, so I'm trying this out with a new recorder, and I've got section 5.1 open. I'm going to introduce you today to nth roots and rational exponents, meaning we're going to start to put fractions in our exponents. This is a continuation of Algebra 1, but again, if you don't remember it at all, we're going to start all over. So these are the things you're going to learn. Hopefully we'll do nth roots of numbers. We'll evaluate expressions using them, and then of course we will solve equations. So think of them as square roots and cube roots, just more. Here's the definition. An nth root, we call him an index, where you see this square root symbol. Only if there's no number there, it's a 2, like a square root. If there is a number, it's some other root, and we call it an nth. So say you want to find the fifth root of 32, that means what number times itself 5 times is 32, and that would give you 5. That n number is called the index. The a is the number underneath, and there's some other terms there, but we can figure out if it's an odd or even integer. We'll go through that in class. Well, I'm also going to show you how to have the calculator do it for you. But for right now, we're going to go back and forth between rational exponents and how to write them. So this right here is the core concept. If you have a base a and it's to the 1 over nth power, then it looks like that. A is under the radicand and the index is on the inside, but you can also raise it to another power m. So a to the 1 over n raised to the m is equal to a to the m over n. Also with a negative, remember, the negative doesn't change the number, it moves it into the denominator. So these things are all equal as well. Of course, a can't be 0. We're going to evaluate some expressions. I will do that with you in class, and I'll also make a video with notes. You can do it with your calculator. Again, I'll show you how to do that on another time. Right now I'm just going through the main concepts of 5.1. So let's say you have something to the 5th power, like this example here, and you want to figure out what x is. So to solve, you undo a 5th power. It's just like undoing a square with a square root, only you're going to undo a 5th power with a 5th root. Same thing here. I've got a 4th power, so I'm going to use a 4th root. And again, we'll do lots of examples. There is a real life application with it, but right now we're just going to work on some problems together. That is the core concept, and like I said, we'll do examples in another video.